Good morning, class. Welcome back to AET 830, Internet of Things and Industrial Applications. So in the last chapter, we talked about some technical fundamentals of Internet of Things. Specifically, we talk about the devices, we talk about the different networks and communication methods. We also talk about the machine intelligence. So for this unit, we will continue with our discussion on distributed cloud and edge computing. Basically, you have heard of cloud computing, edge computing somewhere, maybe. But what do they actually mean? That's what we will cover in this chapter. We'll also talk about the data management and business processes in Internet of Things. So the content for this chapter also comes from the chapter 5 in the textbook. So as we mentioned earlier, there is a general trend from enterprises invest in hosting and operating dedicated compute facilities to run their enterprise applications. Instead, applications are increasingly hosted and executed in remote, located large computer centers. So so to help you get some intuitive impression, so just think of the Microsoft Office software. So maybe still 5 or 10 years ago, you need to buy a computer. You need to buy a good enough computer, and then you need to buy or download the software. Basically, you need to pay some money, buy the disk or download the installation file of the Microsoft Office and install the software on your computer. So that's what was happening maybe 5-10 years ago. But nowadays, you maybe have noticed, sometimes if you're using Google Drive or those things, you don't actually need to download the Microsoft Office software. Basically, those software can be executed or in your browser, basically in the website. Behind that is actually the software is running remotely in a data center or the server of Microsoft. Basically, your browser is just communicating with that remote data center or server and display the information needed. So that's the current trend. Connected consumer electronics like wearable, web cameras, home appliances are also web-enabled and rely on applications that execute remotely. So we list some examples here. For example, Apple Home and also Alexa from Amazon. Basically, you know that you can talk with them, right? But actually, for this kind of device, they don't have the capability to process the your language itself. Basically, what it does is that it records your message, record what you say, and use the network to upload to a very capable server or data center, and then it interprets your language and then give you better feedback. For example, it will tell you where the restaurant is and something like that. So basically, this is enabled by the cloud paradigm. Cloud builds on the notation of sharing computer resources over a network and allow applications to be distributed, both in terms of execution and in terms of reaching user. So the attractive of cloud is the ability to enable economy of scale and cost reduction and resource utilization, and some benefits are also listed here. The underlying technology evolution that enables cloud computing is virtualization of both hardware and software resources, thanks to the technology advance. So virtualization of hardware and software. For the hardware, it means that, for example, for a computer. So if it is a real computer, it's a machine in front of you. But using the virtualization method, virtualization paradigm, basically, you may be able to use a computer somewhere in the world. It is still a physical computer, right? But in your case, in your face as a user, basically you're just facing a virtual computer. So the same also applies to software. So if you are using Microsoft software, basically the software itself is not installed on your device, not in your iPad, but actually it is somewhere in the world, in a data center or in a server. basically in the eye of you, it is a virtual one. So that's what virtualization means. So what it does now is that, so this is the cloud. Basically, we have all the resources, applications, platforms, and infrastructure in the cloud. So we have developers to develop such applications, platforms, and also we have the service provider to provide these applications and platforms. And as a user, we just try to access these resources. So that's the basic idea of cloud manufacturing, of cloud computing. So the traditional cloud model relies on applications that essentially execute in data centers and are accessed by the end users through cloud client devices. However, there are increasing needs and requirements to distribute applications, both from a computing and from a storage perspective. So the cloud can be distributed. Basically, what it means is that instead of using one data center, we can have multiple data centers, right? Each of them may be dealing with different tasks. And also application execution can also distribute it between the data center and the client devices. For example, if you use your iPad, use your computer, basically some calculation may be carried out in your device, and some complicated or high-level computation will be executed by the remote data center. So actually, with this in mind, actually we are reaching some kind of fog and edge computing. We'll have a comparison of them in a few slides. And also, with the cloud represents a new way to deliver software outcomes, which is called software as a service. So if we go back to the illustration of the cloud computing, you see that what we interact is actually services. For the services, it can be application, it can be platform, it can be infrastructure. So most of the time for as you and me, we will interact with software as a service more often. So this is a new means to deliver value to end users. Cloud computing is a model for enabling ubiquitous on-demand network access and shared pool of configuration resources. So it relies on the virtualization for the configuration resources. It can be networks, it can be servers, it can be storage, application, and associated services. For example, now you have a Google Drive, right? So Google Drive is kind of cloud computing service. Basically, provides storage, and also for the Microsoft software, and there are many others. I think they belong to applications. And for servers, so if you use the Amazon AWS server, so it is an example. For networks, an example is that there are some internal network for example, for the NCANT. So basically, if you go to the library, for example, you want to download a paper from the internet. And in that case, you may need to pay if you are standing alone. But if you are able to connect to the NCANT network, and by basically log in with your OneID and password, then you can access those papers using the NCANT network. In that case, the paper can be free. Some virtualization method, so just have an idea, but it's italic. Basically, we don't need you to understand the details. So for the cloud computing, actually, we have a definition from NIST, National Institute of Standards and Technology, Standard and Trademark. Okay, trademark. So it is a baseline for describing what cloud computing is. So based on the definition, there are 5 characteristics that capture the essence of cloud computing, which are depending in the following. For cloud computing, it is on-demand self-service. So basically, a cloud can provision computing capabilities without requiring human interaction with each cloud service provider. Basically, everything will be organized and automated. And also it has ubiquitous network access. Capabilities are available over the network and accessed through standard mechanisms that promote by the different client platforms. What it means is that you can access the Microsoft software using your laptop, using your MacBook, using your iPad, using your phone, something like that. Basically, as long as you have the network connection, you can access these resources. And also resource pooling, the cloud service providers' computing resources are pooled to serve multiple users using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to the user demand. Basically, let's imagine we have a cloud. Cloud basically it is many nodes connected together. So for each node, it can be a data center, it can be a server, it can be an application server, anything. Basically, the resources are distributed on this network. But for the whole network as a whole, it is a pool of resource. That's how to understand this. And if you upload a large file to the, if you upload a large number of big files to the cloud, for example, actually it is very likely that different files are stored at different data centers. So basically, that's how resource pooling can be implemented. And it can have, and for the cloud computing, it will have rapid elasticity. Basically, it means that capabilities can be elastically provisioned and released, in some cases automatically. So if you have many things to upload for storage, they will allocate the resource to you automatically. And also, it is a measured services most of the time. Cloud system automatically control and optimize resources used by leveraging metering capability. So for some cloud resources, for example, the Amazon cloud, those things, basically it is kind of a pay-as-you-use strategy. Basically, if you just upload a small amount of data there, it just charge you a small amount of money. Or if you just deploy one or two applications there, they usually charge less. But basically, the more resources you use, the more it will charge. So it is different from the Microsoft software, right? I mean the older version. So older version, for example, you need to pay for maybe $199 to buy the CD of the software, and then you install it on your computer. Or you need to pay the full price at the very beginning to buy the software. But sometimes after you buy the software, maybe you just use it twice or three times a year. So basically, it is not that economical, right? But for the cloud computing, if it is a measured service, so the more you use, the more you pay. Sometimes it can be a good strategy. So with the 5 characteristics, cloud computing can be offered by service provider in different service models. So basically, to put it in short term, it is everything as a service, or X as a service. So there are 4 main service models at this for now. So let's look at them one by one. The first one is IaaS. So can you guess what I means? I means infrastructure. Yeah, it's here. Infrastructure means it is kind of the hardware. This model basically provides virtualization of hardware. For example, you want to play very good video games, right? Basically, they require you to have a very good GPU, very good CPU, very good memory, those kind of things. It may cost you maybe $5,000-6,000, which you cannot afford. But as IaaS, if you can get IaaS, basically, as long as your own laptop or computer has good network communication, basically you can get access to a very good hardware, computer, somewhere in the world. So it is a virtualization of hardware. Basically, you can use the hardware just like your own good computer. So of course, you need to have good network to make sure that the communication is smooth. But that's the idea of infrastructure as a service. So the gaming computer is an example, but sometimes it can also be a large server, a large data center, those kind of things. Basically, it is the keyword here. It is virtualization of hardware. Okay, so sometimes, okay, you don't need the hardware itself, but you are looking for the operation system. So in that case, we have the platform as a service. This refers to cloud solutions that provide both a computing platform, including all operations, and a solution stack as a service via the network. So to put it simple, if you're a MacBook user, for some of your projects, you need to use a software that can only be installed in Windows, right? So I guess some of you have met this situation. So in that case, you can use this kind of PaaS platform as a service. Basically, you can use your MacBook to connect to a remote computer, and in that computer, you are utilizing the Windows operation system there. And in that case, you can install the software you need and do whatever you need to do. So that's an illustration of the situation. And most of the time, for us, especially for students, we are looking for the software as a service. This refers to complete application software that is provided to consumer on demand as a service, typically via different thin clients and many times through a web browser or application-specific program interface. That's what we mentioned earlier. So if you are using a OneDrive to use the Microsoft Word, PowerPoint, then basically you are using a service as a service, software as a service. So function as a service, it is a recent development that is based on the concept of running code in the cloud without the need to provision or management servers. So basically, it is serverless computing. So sometimes you want to, for example, you write a code or simulation, or you are using if you are doing some data science research, you write a deep neural network. You need to do a lot of training, right? In that case, you can upload the codes, the function onto the cloud. Basically, the cloud will allocate the resource for you to do the training. So in that case, what your own laptop need to do is just to upload the data, upload the codes you wrote, but the cloud will allocate the resources to help you complete the training and then give you better trained model. So that's function as a service. In that case, you don't need to even specify what software you need to use. You just upload what function you want to achieve. If you still remember here, we look at just now, so we can find that IaaS, PaaS, and SaaS. Actually, they correspond to infrastructure as a service, platform as a service, application as a service, and for the function as a service, it also belongs to the applications resource. Okay, that's the 4 different types of services cloud computing can provide. So cloud is commonly associated with publicly available cloud-based services like Microsoft Azure and Amazon Web Service. However, there are several different deployment models for cloud. So we have the private cloud. So usually it is something used only within the building, within your house, or maybe within the university. And we have a community cloud. This is provision for exclusive use by a specific community or consumers of organizations. For example, for the UNC system, UNC stands for University of North Carolina system. There will be a community cloud. Basically, the resources can be provided by all the UNC universities. And of course, we have the public cloud. Basically, it can be accessed by everyone. And sometimes we can also have a hybrid cloud. Basically, it is composition of two or more distinct in cloud infrastructure we mentioned just now. Okay, by this moment, we're talking about the generic cloud manufacturing, cloud computing. Yeah, I keep saying cloud manufacturing because that's what I was doing. For cloud manufacturing, cloud computing, so most common office and consumer applications are well suited for implementation in large centralized data centers because they are more capable, right? But in recent years, so people are promoting fog and edge computing. Let's see what's happening here. So there is an increased need to both build distributed cloud solutions as well as taking computing to the edge. So edge means that, so if the data center, so remember the figure we draw last video, I think. So we have the devices, right? And the devices will be connected to the gateway system, gateway device, and the device will be connected to the cloud or to the internet, right? So under this schematic, basically your device, you can consider it is at the edge of the network, right? So if this is the case, so basically edge computing, as you can guess, is to let your device, or basically let all the devices in the cloud on the edge do some computing. So previously we are just relying on the big data centers, maybe deep in the network to do the computing. But people later on, they say, oh, let's see that we have many devices connected at the edge of the whole network. So they also have the computing capabilities. And most of the time, many of them are idle. Basically, they are just sitting there. They don't do any computing. They don't make use of their capabilities. So people are thinking about, okay, instead of, in addition to letting the big data centers doing the task, we may also distribute the task to some idle devices in the network. So there is an increasing need to taking computing to the edge. So in that case, we are talking about taking data to computing or the computing to the data. If we are taking data to computing, that means that we upload the data all the way to the, for example, to the data center, and then the data center process it and get back the result. Take the computing to the data. That means that, for example, for a smart sensor, it collects the data maybe in your room, for example. Then we bring the computing capabilities there. Basically, we will have a better microprocessor, and then the computing can be carried out on the device in your house. So that's what it means. The intention of enable distributed processing is not to move away from the data center approach, rather to extend the cloud computing paradigm so that the computation and storage can take place anywhere and not only at the dedicated data center. So for edge computing as well as for computing, the NIST again is trying to provide a terminology, and for our case, we have an adaptation of the terminology for the different situations here. So we have cloud, so we typically large data center with globally applicability and reach, so globally. And we have distributed cloud. There are still big data centers that cover regional or national needs. And down there, all the way down, we have the edge. It's the network layer for smart end devices. For example, your iPad, your computer, that's the edge. And anywhere between the cloud and the edge is what we call fog. Fog computing places the cloud computing paradigm of virtual resources between the smart end devices, which is the edge, and the traditional cloud or data center, which is the cloud. So in that case, if we use a figure to illustrate, so for the device here, right, it belongs to edge, no problem. For the regional and global data center, they are cloud, no problem. And the places in between, For example, we have the micro data center, we have the gateway. For example, your Wi-Fi router, it can do computing, right? And micro data center, so they can be considered to be four. But of course, sometimes the boundary is not that obvious. But that's the idea. Basically, we want to smartly distribute the storage and computation to every element in the network, not only the edge, not only the data centers, but also the resources between them. The main motivations for why distributed processing is of particular relevance for IoT can be viewed from four main perspectives. Basically, why we want to distribute the processing. Basically, we can understand this from the physical assets and infrastructure things and operational technology viewpoint. We can also look at the performance aspect. For example, if we need to make a assessment of time to insight or time to action. So for example, if something that needs fast reaction, so it may be a good idea to upload the data all the way from the smart device to the cloud data, to the data center, and then wait for the results coming back. For example, if you are controlling a robot, if a robot is controlling itself, so definitely you want the computing, at least most of the computing, for example, the sensor feedback, the closed loop control to be implemented on the robot, right? On the other hand, if we want to get insights or from some complex or large amount data, then we may be able to upload the data to the data center for processing. Also, another motivation is cost reduction. By aggregating data using local processing, data volumes can be reduced and the level of data can be kept at an appropriate level. For example, if you are measuring the temperature of a room, so or maybe of a region, so basically you don't need to do very frequent measurement. For example, you just need to measure a temperature maybe 1 minute, every 1 minute, or maybe every hour, something like that. In that case, most of the processing can be done on the smart device itself. What it does need to do is just to provide one number every hour, for example, so that the communication load is low, and also the data center does not need to store that much data. The last motivation for distributed processing is related to legal, privacy, security, safety data. For example, some data you just don't want it to be uploaded to the cloud because if it is on the cloud, it is on the data center, there is always a leak and there is always a risk for leakage, or maybe some bad guys may make use of it. So maybe you have heard of that some people are actually selling users' data. Basically, sometimes when you pick up a phone from a number which you don't know, they can exactly call your name and also tell about where you are living. So that's actually kind of the issue. So for me, actually, I don't turn on the iCloud on my iPhone because, yeah, who knows whether your photos, your videos will be accessed by other people. After talking about the cloud and the edge, so fog is by definition between the data centers and smart end devices at the level of wide area network infrastructure and the internet itself. So after learning about the cloud, the fog, and the edge computing, so let's have some conclusions and considerations. The cloud paradigm is equally applicable to IoT solutions and also in many other areas. The benefits of sharing resources from a pool can allow elasticity in scale and pay per use appealing. So the platform as a service is of particular interest, and infrastructure as a service and software as a service also have their attractiveness. In the IoT platform as a service setup, it will also provide a solution stack as a service. Basically, if you, first of all, platform as a service means that you can use different operation system, right? just as the example I mentioned earlier. So if you are using a MacBook, then you will be able to use Windows operation system by using the PaaS service. For the PaaS service, we not only need the operation system, but it will also provide a solution stack. Basically, it includes different tools for device integration, security, and exposure. Basically, you have these items on the solution so that your current platform, for example, the MacBook, the iOS, Mac OS, can integrate and work smoothly with the Windows. Basically, you need these items. I can leave this reading to you. Basically, they talk about what should be included in the platform as a service solution stack so that you can use it smoothly. So all additional consideration, the choice of public, private, or hybrid deployment models is largely a trade-off between the cost, the trust, confidential of operations, something like that. Where to process and storage in terms of data center and the edge is combined consideration of performance, cost, and autonomy of applications. And also the choice of global data center and regional data center is consideration of legal aspects around treatment and customer and citizen data. So some data, for example, for the national security purpose, so some data should not be accessed by other nations, right? In that case, a regional or national data center is needed. So finally, as mentioned, cloud computing is also a good example of an enabler of new business models. We'll talk about business models as the last part of this section. It will also enable rapid creation and rollout of new applications.